Hello all, welcome back to Sri Sai Tech Edu YouTube channel Read Lead Success. I am dealing with the subject network analysis and control systems. I've already done the module 1 and module 2 videos and already uploaded in my channel. If you have not watched, please do check out. Now I'm dealing with the module 3, that is basic concepts and representations. I've already done many of the topics under this, already uploaded the those videos. So in this video I'm going to deal with the new topic. As I told, I completed till analogous system. The previous video I've already done problems on mechanical translational system. In this video I am going to do mechanical rotational system problems. After that I'll go for block diagrams video. Problems on mechanical rotational system. Till now we have seen the translational system. Here the rotational system we are going to see. The rotational system looks in this way, where shaft stiffness and a disc with the theta is the displacement, angular displacement. Theta is the angular displacement here, as I told in previous videos also. T is what? Torque. F is viscous fluid, K is this the stiffness or the spring. So after seeing this diagram, we need to draw for this the free body diagram, same like the translational system. Here in question they are asking torque equations need to be written and transfer function theta of S by T of S. Also obtain the analogous electrical network based on torque voltage and torque current analogy. After that, after writing this free body diagram, what we will do, we know that torque is nothing but moment of inertia into angular acceleration. So we will write separate equation same as translational system, that is for initially for the J element, that how same like that only we are going to write the free body diagram. See, first initially we will write J and the F into d theta by dt. Why? Because there is an F element, F into d theta by dt, F into d theta by dt, and there is a K, that is spring, K into theta, and here we are going to take as torque, not the force, torque, and theta is what? In the place of x, theta. Why? Because it is angular displacement. Okay, after writing the free body diagram, what we do, we write separately. For J, what we write? J into d square theta by dt square, and for F we write F into d theta by dt, and K into theta. Total what it will become? Adding this all. After that you will take Laplace transform, same like translational system. T of S will become J is equals to Js square theta of S, and F into S into theta of S, and K theta of S. What we want? Theta of S by T of S, that is transfer function. So if you take theta of S from this equation common, you will get theta of S by T of S is equals to 1 by Js square plus Fs plus K as the transfer function. And then now again what they are asking, torque voltage and torque current analogy and analogous electrical current circuits. For torque voltage, we should remember that the left hand side, the torque will become the voltage part, and J will become L, and R will become F, and K will become 1 by C, and the theta will become Q. And you can write this in terms of I also. E is equals to L into di by dt, R into I plus 1 by C into integral I dt. Why? Because the formula I is equals to Q by T. So in this way we are going to write in terms of, in place of Q we can put I. So after writing the equations, we need to draw the electrical circuit. Electrical circuit is same like translational system. You will write the torque current. No, we should take the current supply, that is E is equals to, I'm sorry, here it is not E, here I is equals to, sorry, it is torque voltage, no, it is voltage. So E is equals to T, I'm very sorry, it is E is equals to T, and in series with always the voltage. Here the notation I took wrong, here it should be plus minus. Here the notation is wrong. See, torque voltage means in this way we should write, and torque current means this way we should write. Okay, this should be not there. Torque voltage is plus minus we should write. If I will clean this out, 1 minute. Just erase this. This is not there. This is torque voltage, no? So voltage part should be here, and torque current means current we need to take here. So torque voltage means voltage part need to be taken first in the electrical circuit. E we will write. After writing E, you know that E with the voltage will be in series with the resistances. So L will become J, R will become F, and C will become 1 by K. And you will write in the series form. Now torque current analogy, how to write? The T total torque will become I, J will become C, F will become 1 by R, K will become 1 by L, and the theta will become phi in the torque current analogy. In this again you can write in terms of E, that is I is equal to C into dA by dt plus 1 by R into E plus 1 by L into integral E dt. Again for the torque current analogy we will write the electrical current circuit. T is equals to I, we will take current source, with that the resistance will be in the parallel. So C will be J, R will be 1 by F, L is equals to 1 by K. Simple. Okay, like this same, how translation system we do, no? In the same way we will do the rotational systems also. Obtain the transfer function of the mechanical system shown in figure. This is the mechanical system, mechanical rotational system. For this we will draw the free body diagram. How to draw free body diagram? J1 you are going to take, J2 you are going to take. In between J1 and J2 there is K. So you will take K in both sides. In rotational system, the K direction will take this side also and this side also, and take K into, this is theta 1 and it is theta. So theta 1 minus theta. Okay, and there is F connected to this side, right side. So you will consider F into theta dash. That is nothing but F into d theta by dt, and theta is in this direction. You will write in that direction only. Again left side, the torque is given, so torque also you will mention and write the theta 1 of t. Understanding? The displacement, angular displacement, everything need to be mentioned here. In between this both direction you should write the diagram, and K into theta 1 minus theta need to be taken. Why? Because when you are considering J1 you will consider K into theta 1 minus theta, and while considering J2 you will consider theta minus theta 1, theta minus theta 1. So we are taking both the directions here. Understanding? Then the differential equation describing the behavior of the system in figure are as follows. We will write the differential equations. For T1 of first we will write for J1. For writing J1 there is T, that is equals to J1 d square theta 1 by dt square, and K is connected, so K into theta 1 minus theta. Why? Because it is with respect to 1 J1. Or you can write T is equals to d1 by d into omega 1 by dt plus K into integral omega 1 minus omega dt. Why? Because theta, angular displacement, can be written in terms of angular velocity also. Understanding? How we write displacement in terms of velocity? In this, angular velocity will be written in angular displacement will be written in angular velocity. So please understand this. In even the table also I told the differences what we need to consider. If you keep that table in mind, what I did in the previous video, that is the table with all the comparison between the translational systems with force voltage and force current analogy, and the comparison, you'll understand. Then for the J2 there is no torque present, so you will take 0, and J2 into d square theta by dt square, and for this there is F, so F into d theta by theta, plus there is K, as it is with respect to the two side the displacement is theta, so K into theta minus theta 1. Again you can mention in terms of omega also, you can write in terms of omega also. So what they are telling in terms of angular displacement, in terms of angular velocity, keep that in mind. Then taking Laplace transform, what you get for the first equation, T of S is equals to J1 S square theta 1 of S plus K theta 1 of S minus plus K theta of S plus K theta of S. No, not plus. Why? Because it is minus only. Why? Because here it is k theta 1 minus theta. So k theta 1 of s minus k theta of s. And you will take the theta 1 of s common here. And for the second equation, 0 is equals to j2 s square theta of s plus fs into theta of s plus k theta of s minus k theta 1 of s. Again take theta of s here common. After that, from here we can find the what? Theta 1 of s. Theta 1 of s transfer function we want. No, transfer function means what? Output by input. Output is theta 1 of s. Input is theta of s. So theta of s output is what? I'm sorry, here output is what? Input is torque. Torque is the input. Output is theta. Theta. So theta of s is the input. Theta of s is the output and applied input. Why? Because in the diagram only they have showed that applied torque is T, output is this. So output by input, theta of s by T of s we need to find. How to find? We can't find because directly, because here the terms are in terms of theta 1 of s. Here also there are in terms of theta 1 of s. What we need to do? From this equation we need to take theta 1 of s. How? j2 s square plus fs plus k theta of s by k. This will become, from this equation we can write theta 1 of s. This if you substitute in this first equation, t of s j1 s square plus k, theta 1 of s is what? Here theta 1 of s is j2 s square plus fs plus k by k into theta s minus k theta of s. Now it is in terms of t of s and theta of s. So take theta of s from this common and send that t of s to the right side. So you will get theta of s by t by s, that is equals to this equation. So nothing but we need to eliminate the theta 1 of s, can get theta of s by t of s. What we are doing from the second equation, we are taking the theta 1 of s equation and substituting in the first equation, so that you will get in terms of t of s and theta of s only. Next question, write the torque equations of the rotational system shown in figure. Then also find the transfer function theta 1 of s by t of s. They are asking for theta 1 of s by t of s. Okay, we'll find. Obtain the analogous electrical circuit based on torque current and torque voltage also they are asking. Okay. First, we'll find the transfer function. For finding transfer function, again write the free body diagram. J with k is between the f and j. So k theta 1 minus theta 2. In both directions we are going to mention. Why? Because it is between. And f theta 2 dash, and torque is in this direction only, mentioned in that way, and theta 1 of t need to be mentioned. After writing this the free body diagram, write the differential equation. I am not going in depth. Write the differential equation in this form. Then after writing in this form, but here you need to keep one thing in mind, is that here one wrong is done in the textbook. What it is here it should be omega. Keep that in mind. Why? Because we are considering angular displacement, so it should be omega. Even I didn't check it, from textbook I copied, so this will be omega. Okay, better I'll mention here. I'll mention here that replace v by omega in this equations, this and this and this equation. They have given wrong in the textbook. Why? Because angular theta will be written in angular displacement. Angular theta is nothing but angular displacement. Omega will become angular velocity. But here v1 is taken. It is wrong. Keep that in mind. After that, this equation, why? Because there is no torque, you will take 0. Write these two equations. Then take Laplace transform. After taking Laplace transform, you are going to get in this these two equations. That is this equation and this equation. From this equation, if you see, again there are theta 1 of s, theta 2 of s. You want theta 1 of s in the equations. What you should do? From the second equation, just take out the theta 2 of s equation and substitute this fourth equation in the third equation. Okay, then you will get T of S Js square plus K into theta 1 of S minus K into theta 2 of S is what? K into theta 1 of S by Fs plus K. As it is in terms of T of S and theta 1 of S, if you take this divided by theta 1 of S by T of S, you will get this equation. Substitutions. Why I am telling you this way? Because even translational system also I have explained very clearly. So in the same way you are going to do anywhere. So in detail I didn't go, just the procedure I told for this. This is the continuation for the third question. What they asked for torque current and torque voltage analogies. Already we have the equations, main equations. From that you are going to mention in place of T you are going to take I and J, C and F as 1 by L and F as 1 by L and K as 1 by R. Like that you will take. After taking, you can write this phi as E. Here also phi as E for the both equations. In the same way you will convert the respective components to the L 1 by C, and you can write in terms of Q also, in terms of I also. After writing this, you will write the electrical circuit, that is current will be in parallel with the resistances. So C is in parallel and R is in parallel, but this K is not in parallel, or the inductance is not in parallel. Why? Because this is in between J and F. So in between J and F we are writing this. Keep that in mind. And for voltage circuit, torque voltage circuit, here also if you see they have written wrong. It is force not, it is torque. Torque current voltage, torque current analogy and torque voltage analogy. If you see again for voltage, what you will have, it should be in series resistance. And if you see J and F are in series only, but K or the capacitance which is between will be in parallel. This is the opposite way. Okay. Next question. Write the torque equations of the rotational system in figure. Find the transfer function theta 1 of S by T of S. We want theta 1 of S by T of S. Here where is theta 1 of S? Here theta 1 of S by T of S. This T of S they are asking. Okay, we'll find that. And if you see here, it is little bit different, so I'll explain you clearly. Here motor is given. So how to write? First you write the motor. For motor, what all are connected? Theta m of t, theta m t of t, theta m t of t. Right off. Then if you see in between motor and J2, there is one K element. So K2 will be written in terms of theta m minus theta 2. In both directions we are going to mention. Again for J1 also there is K1. In both directions you are going to mention K1 into theta m minus theta 1. Understanding? This is the free body diagram. After that write the equations. How T of T is equals, first we need to write three equations here. First equation will be T of T. For this Jm will write Jm into d square theta m by dt square. It is connected with K2 and K1. So K2 with respect to m we are taking, no. So theta m will be first and theta 2 will be next. Theta m minus theta 2. Again K1 into theta m first, theta m minus theta 1. Then for the second equation, there is no torque present for J2. So it will be 0. Then J2 into d square theta 2 by dt square plus, which is connected to K2. So K2 into, with respect to 2, no. So K2 into theta 2 minus theta m. In the same way, for the J1 also you will write. After writing these three equations, now we are done with the writing the main equations. After that, if you take Laplace transform, you get this fourth equation, fifth equation and sixth equation. For that three respective equations. After that, we want what? Theta 1 of S by T of S. So the whole equation should be in terms of theta 1 of S and T of S. So what we can do from equation 5 and 6, if you see, this is also in terms of theta m of S, theta m of S. Theta m of S can be written as, in this, from this equation, J2 s square plus K2 into theta 2 of S by K2. Again theta m of S will be equals to what? J1 s square plus K1 into theta 1 of S by K1. So both will be equal equations. So both this equation and this equation will be theta m of S only, equals to theta m of S only. So from this you can see theta 2 of S can be written in what? J1 s square plus K1 by K1 into K2 by K2 by J2s square plus K2. See here clearly, carefully. If you see, theta 2 of s will become what? This whole equation by this equation. Okay, theta 2 of s. So, what happens? K2 will go up. So, K2 by K1 will become, and J1 s square plus K1 by J2 s square plus K2 it will become. So, theta 2 of s value you got. Theta m of s value you got. Put those two values in the equation 4 which we have. So, T of s is equals to Jm s square plus K2 plus K1. Theta m of s value is what? J1 s square plus K1 by K1 into theta 1 of s. You may have doubt. Why theta m of s you are not taking this one? Why? Because we are not required with the transfer function of theta 2 of s. We want theta 1 of s. So, which is in terms of theta 1 of s, that equation need to be considered for theta m of s. Understanding? Then theta m of s, then minus K2 into theta 2 of s is what? You got as J1 s square plus K1, J2 s square plus K2 into K2 by K1 into theta of 1 of s minus K1 theta 1 of s. After substituting, you will get this equation. This is the transfer function. Then after transfer function, and in some more calculations are there. If you do those calculations, therefore the transfer function, if you should multiply those all things and do how much ever you can substitute, how much ever you can calculate. No, calculate and put the last value. Try to multiply as possible and put the final value which is present by taking common j s square s for 4 s power 6, like that. You take common and find the final transfer function. Next question, write the differential equations governing the mechanical rotational system shown in figure and determine the transfer function theta 1 of s by what? T of s. Now how to find? The same way, write this equation in terms of what? Free body diagram. Write J1 first. If you see K1 and F12 are in what? In the between J1 and J2. So K1 you will do 2 times. K1 opposite, both up and down directions you are going to write, and F12 also up and down directions, both that side and this side directions you are going to write. F12 theta 1 dash minus theta 2 dash, F12 theta 1 dash minus theta 2 dash. Understanding? And other T theta 1 the same will be there, and here theta but there is another F element, so it will be in the opposite direction, that is F theta dash. After writing the free body diagram, we will write what? Same. Write the differential equations. For J1 first we will write. For J1 if you write, T will be equals to what? T will be equals to J1 d square theta 1 by dt square. If you take this side, plus F12 d theta 1 minus d theta 1 by dt minus d theta by dt, and K1 into theta 1 minus theta. Then you can write that theta is in terms of angular velocity, also omega. For the second equation there is no torque, so it will become 0, and write the equation accordingly for J2 also. After writing, what we will do? We will take Laplace transform. Laplace transform of first and second equation. First equation Laplace transform will be like this after taking theta 1 of s and theta s common, and the next equation Laplace transform will be this. And as we want theta 1 of s and theta t of s, this equation, from this equation what we should do? From this, the fourth equation, take the theta 1 of s common, theta 1 of s on the left hand side. So you will get J2s square plus fs plus f12s plus k1 into theta of s by f12s plus k1. You will get theta 1s value. Substitute this in the third equation. What they are telling? Substituting the equation theta 1 of s from equation 4 to equation 3. What we will get? T of s is equals to what you will get? J1s square plus f12s plus k1 into theta 1 of s value is what? This is the value. You will substitute that, minus f12s plus k1 into theta of s. After that, if you want theta t of s, you need to take the theta of s right side common and do the necessary multiplication. Then after that, you want theta 1 of s by theta 1 of s by t of s as the transfer function. So if this is not theta of s, is theta 1 of s. Then after that, if you take the T of S is equals to, you will get this. After you need to substitute how much ever possible. Then write theta of S by T of S by as F1 to S by K1 and the denominator value. By taking how much ever possible, try to multiply and take the commons to get the finalized transfer function. Next question. This is an important question. Why? Because this is the previous year question paper. So I am solving that also. They are asking for differential equation for the given figure, rotational system and analogous circuit based on torque voltage analogy they asked. Okay. It's easy. We have done in previous questions also. Same way. If you see here, there is 3 J elements. J1, J2, J3 and T of T, theta 1 and theta 2, theta 3. First mention these all things. After that, we want what here, if you remember, even in electrical, what our translational systems also I told, even though the dashpot is not mentioned in this way, even if it is mentioned in the as the arrow mark to the J element or the mass element, then you need to consider that also. As it is with respect to J1 only, we will consider B1 theta 1. And for B4, it is between theta 1 and theta 2. So we will take B4 into theta 1 minus theta 2 in both this direction and this direction. After that, for B2 also it is written in same way. So B2, if something written in the like this in arrow mark with respect to that element, so no need to consider theta and theta 2 and theta 3. With that respect to mass element or the J element only you should consider. Nothing but P2 into theta 2. And there is a K1 element between J2 and J3. So K1 into theta 2 minus theta 3 and opposite direction also you should consider. Then later you have K2 with respect to only theta 3 is there. So K2 theta 3 and another B3 is also there with respect to J3. So B3 theta 3. Understanding what I am telling? Why I am not taking B1 as theta 1 minus theta 2? Because it is only for this J1 element. It is not between this theta 1 and theta 2. If it is between like this, then you should take theta 1 minus theta 2. If something mentioned that arrow mark down the mass element, the block, then you should consider like this B1 theta 1 only. That respect to displacement only need to consider. After taking this free body diagram, everything is same. Writing the equations is same. This writing free body diagram and finding which elements and how to do write, that is only main thing. After that you can easily write T of T is equal to J1 d square theta 1 plus d square theta 1 by dt square plus B1 into theta 1 by dt plus B4 into d theta 1 by dt minus d theta 2 by dt. Same way for others there is no torque, so you will mention 0. In the same way you can write for in terms of angular velocity also, as I said. That's it. But if you want the electrical analogous circuit based on TV analogy, then what we should do? We need to convert the 3 equations in terms of the inductor, resistor and capacitor with respect to inductor capacitor. For example, they are asking here for the torque voltage. So the torque will become E and the J will become L and the dashpot, that is B1 will become R1, B4 will become R4, and whereas the K element, the spring element will become 1 by C1. And this Q terms can be written in terms of I also. Can convert them. For the circuit, how we will draw? Same the rules we followed previously. As we know, voltage will be in series with the resistances or inductor or capacitor. Here L1 J1. Okay, torque with L1 J1. Okay, but B4 is in between J1 and J2, so R4 will be in between. Again you have L2 J2 and B2 R2. Again the K1 is in between J2 and J3, so it will be in between. C1 will be in between. Again B3 and L3 or J3. L3 will be equals to J3, B3 will be equals to R3, and if you can see B3, J3 and K2 will become the again in this way. So keep this in mind how to draw the electrical analogous circuit for the mechanical, rotational or the translational circuit. Same way In one more thing what I can say is rotational and translational system, torque voltage and torque current analogy conversion is same. The E will become T, but there F, here torque. So you should know minimum changes, so that you should remember the table what I mentioned in the video of analogous system, and I explain about mechanical rotation, mechanical modeling systems and electrical systems. Those three topics, 4, 5, 6 topics what I told you, those are very important. So these are practice questions you can solve and try to get the answers. If you have any doubt, you can comment me in the comment box. As I said, this 4, 5, 6 which are their concepts are very important. From that table only we have solved the two videos, the previous video what I have uploaded and what the video I am doing in this. No, both are based on mechanical system elements, based on the tables mentioned or the formulas mentioned in these three topics only. And converting to electrical system, in analogous system, how they are called analogous and what are the differences, I have all explained. So please watch these three videos, then do the sums. It will be very easy. Okay, so I am stopping the video here. For the next video, I will start with the next topic, that is 7th topic, block diagrams and its sums, and next signal flow graph, so that by this you can complete the module 3. Okay. Thank you from Sri Sai Tech Edu YouTube channel. Read, lead, success. Keep reading.